Hi guys, I hope you had a great day. Thank you for joining me on the last hour. I know you're tired, so I'm gonna try to entertain you. Let's begin. Okay, so dependency injection in KOtlin. First of all, let me introduce myself. My name is Salomon Brys. Most of my work, or I should say most of my important work, is on GitHub. And I'm here today to talk to you about dependency injection. So, this is what Wikipedia has to say about the topic. It separates the creation of the client dependencies from the client's behavior, which allow the program designs to be loosely coupled and to follow the dependency inversion and single responsibility principle, blah, blah, blah. Lots of words to say two things. The first thing is separation of responsibilities. It's important because it allows multiple teams to work on the same application, provided that they give to each other the same contract, the same interface. If teams can agree on interfaces, then they can work on different modules, and that's why separation of responsibility is important. Doing dependency injection also has a very good benefit. It allows testability. It means that your module can be tested, unit tested, and that your module can work in and out by itself. So this is Microsoft's way of describing dependency injection. In fact, the dependency injection library is really the builder. The builder creates a client and provides to a client its dependencies. All the client has to do is to describe which dependencies it needs. In essence, this client needs a service in the form of the iService1, the interface, and this interface will be provided to the client by the builder in the form of an implementation. It's very important to understand that the client has no idea of what is the implementation. The client needs a service, and the service is provided to it. So in this talk, when I'm talking about Kodein, which is the library that I'm going to introduce to you, I'm talking in this diagram of the builder. So what can you inject? Okay, the first and foremost thing that that comes to mind is business managers, and that makes sense because business managers are different modules containing your business code. It interacts either with the UI or with the database or with the network, and it can and should be unit tested. But that's not the only thing that you can inject. You can inject presenters, controllers, or view models in if you're using MVP, MVC, MVVM, and all that jazz. And you can actually inject the builders, the factories for those UI toolbox. Of course, if you use the repository pattern, you can inject repositories, and you can even inject OS services. And in fact, that's what the Android system is doing for you. When you are requesting, for example, a vibrator, you are requesting an object that implements the vibrator interface, and the dependency injection Android system will inject that, will give you an implementation of that vibrator, depending on if you're in the app or in the unit test or what have you. In fact, anything that can be abstracted can be injected. Maybe not everything, but almost everything. So at this point, the question that you should have in mind is this one. Okay? Why? Why would I pester you at 5 in the afternoon about dependency injection? Because everybody know and love Dagger, which is an amazing piece of tech. And, you know, why am I here? And I'd argue that I'm here because KOtlin. Okay? KOtlin allows us to do things differently than Java. Dagger is tailored for Java. Java does not have a lot of tools and, well, Java does not have the tools and syntactic sugars and modern construct that Kotlin brings. So maybe there's a better way to do injection in Kotlin than to use reflection-based API or to use code generation paired with annotations. So what are the goals for a DI library in Kotlin? Okay, what are we looking for? And this is my pick. My pick is that first and foremost we're looking for something semantic. I want to say that if I'm binding this with that, I want to write bind this with that, and that seems. I want to read my code and understand it immediately. Okay, so I want a simple declarative domain-specific language. I also want it to be idiomatic. Okay, it means that I'm programming in Kotlin. I've chosen Kotlin. My application is in Kotlin. I want to use something that uses Kotlin, that makes me feel that it is part of a whole. That whole being the Kotlin way of thinking. Of course, I want it to be easy. Okay, I want to be able to add 3 to 4 lines of code and get on with it. Add my modules, inject my dependencies. I don't want to have to create 3 classes, add a lot of annotation, reference classes between them. I want things to be easy. I want to add the library and use it in 3 lines of code. This is the mobilization conference, so I don't have to tell you why I think it should be Android friendly, but I also think that it should be Java friendly, meaning that not all of us have the liberty of using Kotlin for all the application. You know, you can take an application, an existing application, breathe Kotlin into it, and the dependency injection system that you use should be compatible with the Java code. But that's not all. Kotlin is coming to iOS through a project named Kotlin Native, which is currently in developer preview. And I want my DI system to be as broadly compatible as I can, because I want to share code between targets. Okay, and if we take a step back, we can see that most of those goals are in fact achievable through Kotlin. Okay, Kotlin gives us the tool to be semantic, idiomatic, easy, and even soon iOS friendly. So now this is the time we're at. Ta-da! Here's Kodein that hopefully achieve these goals. Okay, I don't have internet, so there should be a web page that I forgot to configure the Wi-Fi, sorry. This web page should show you how documented Kodein is. There's a huge documentation on Kodein. Kodein is mature. Kodein is very well documented. Kodein is featureful. So of course I'm not going to show you all of Kodein, and please refer to the documentation because it's very thorough. So before I'm talking about Kodein, I want to talk to you about a bit about Kotlin, because we don't like magic in our trade. We want to understand how things work, and we want to understand why things work. So to do that, I'm going to talk to you about 2 small features of Kotlin that are in the core of the Kodein library. The first is the INFIX function. Let's take a function register that applies on a user, so it's an function, and a function at that applies on a DSL. The register function returns a DSL, which makes the line user.register event.at noon understandable. Okay, I have a function that returns a DSL. On that DSL, I call at. Well, that's readable, but Kotlin can do better. Kotlin can do INFIX function and remove the unnecessary dots and parentheses. And now I can read this as a sentence and say user register event at noon. and I understand it. I don't have to understand per se by reading which are the object, which are the parameters, and which are the methods. Okay? If I think about it, it becomes clear that user is an object, register is a function, event a parameter, and that at is also a method, and noon is also a parameter. But when reading this, I don't have to, because I understand the DSL. The DSL is user register event at noon, and that's understandable. So that's the first feature that Kotlin brings to the table. The second feature that I want to talk to you about is called REIFIED generic. And it's a bit more complicated. Now, if I were to run that code, it would fail. Why? Because type erasure. Type erasure is the JVM word for saying, okay, these generic are known at compile time, at source code, but the JVM itself has no notion of the type. For the JVM, when the code is compiled, the type is erased, and then the JVM only sees any, which is object in Kotlin. So when the code, the compiled bytecode arrives to this instruction with getting the class for type T, it's impossible because the type has been erased. So Kotlin's answer to that is inline REIFIED. Inline means that the function will not be called, but that essentially the text of the function will be replaced at call site. And because the function is inline, we can use the REIFIED T. REIFIED means I tell the compiler that it must know the T at compile time. T is a type that is valid at compile time. And if the compiler knows T, then it can replace, because it's an inline function, it can replace T by the real type. And so, if we're looking at this method, we can see that this method does not take a parameter, but we can consider the manager type as a parameter. And it works because the manager type is reified inside the instance function. But we can go a little bit further and see this. Okay? I'm not even passing the manager type to the function. So how the hell does the compiler knows that which type to put instead of the T? And that's called type inference. And in fact, the compiler understands that because you're using the instance function, you must be wanting a manager. Thus, the T generic must be the class manager. And now you have implicit parameters that you don't even have to tell the compiler, because it will infer this from the type of the variable that the type of the value, sorry, that you are trying to get. And Kodein heavily uses this feature to have a result that is understandable and readable. Okay, so no more Kotlin. We're all tired. We want to go party. So let's talk about Kodein. The first thing that I said is that a DI library in Kotlin should be semantic. It means that I want a simple declarative DSL. So how do I construct a Kodein object? Simply by creating a Kodein object with a lambda. In this lambda, if I want to bind a database to a singleton containing a database implementation, I'll just say so. I want to bind a database with a singleton containing a database implementation. And that's the core idea that Kodein is based on. It's this idea that dependency injection and declaration should be readable. By the way, have you noticed the INFIX functions? No dots between the with, no parameters. Everything reads almost like a sentence. Thank you, Kotlin. Okay, so you can bind multiple things. You can bind, for example, an instance, which is an object that implements the interface that you are binding, that exists before even the Kodein object or before your dependencies are declared. For example, a static object or what have you. You can bind a provider. A provider is a function that will be called each time you need an instance. So in this example, a new secure random will be created each time a client class of the dependency injection library will ask for a random. So notice that this is a function. It is not called at the moment when you are declaring your dependencies. Because it is a lambda, so it is a function, the function is stored, and this function will be called each time you need a new random. If you need a singleton, such as a network object or API or what have you, this is the same syntax, except you use the singleton scope, and the same is true. This is a lambda that will be called only once. Of course, it is thread safe, so this lambda will be called only once, and you will have the same object, the same net object, or net amp object will be returned every time you ask for a net implementation. Kodein also supports factory bindings. The simplest is the factory scope. It means that it asks for a parameter and it returns an object that is constructed in function of that parameter. The factory is essentially the same scope as the provider but with an argument, meaning that this lambda will be called every time an instance is needed. And there's the multiton scope. The multiton scope is essentially the same as the singleton scope with a parameter, meaning that the lambda will be called only once per parameter. So if you ask twice an instance with different argument, it will be called twice. With the same argument, it will be called only once. Okay, so that's all well and good, but how do we handle transitive dependencies? Transitive dependencies are dependencies of dependencies. Okay, so there are multiple ways to handle them. Here, this is the way to handle them at construction. Okay, this is the way that Dagger mainly uses. Okay, I have an object and I need the dependencies at construction. Please give me my dependencies. First, I want to attract your attention to this new syntax. This new syntax is to avoid saying I want to bind a repo to a repo. Okay, when you're binding a type to itself because you're not using an interface, shame on you, but you can use this syntax. So we have a repo class that is at the top of this slide, and it takes a database and an object that is called appinfo, because why not? So the question is, how do I get instances of database and info inside the lambda that is my binding? Well, the answer is very simple. You want instances, so ask for instances. And because of the REIFIED generics, the compiler will understand that the first instance is an instance of database, the second instance is an instance of appinfo. No reflexivity is used there. It is the compiler that will infer at compile time the type that are needed. Of course, a good dependency injection library should produce a way to modularize, because you want to have different teams have their own module and then import all those modules. So say that I have an API and I want it to be an API module. It's very simple. It's the exact same syntax, but you don't declare a Kodein object, you declare a Kodein module. Then when you create your Kodein object, simply import the module, and you're good to go. You can continue binding. Of course, testing is supported. So you have your whole app module, and you want to bind the whatever interface a second time. And rebinding in essence, overriding is forbidden, because it is more often than not an error. Because you've already bound the type, and you've bounded, and you're trying to binding it in another place. Well, this is an error. If you want to override, and the use case here is really in a test, in a test code, then you can say so. And the Kodein system will check that it is an override. It will not let you bind the whatever interface if it is not an override, because everything has to be in place explicit. If you're stating that you're overriding a binding, then it should be an override. Okay, lots of things that I don't have time to talk today. Tagged bindings, overrides. Actually, I just added the slide 2 hours ago, so sorry about that. Eager singleton, which are singleton that initialize directly instead of initializing the first time it is needed. Soft and weak singleton, should you need to handle memory. 190s, custom, what? 190s. Maybe we should talk about that at a mobilization conference. So let's talk about that. If you are using Kodein in Android, then your application may look like that. First, there's this Kodein-aware interface. What is it? Just wait for a few minutes, we'll come back to that. Then, Kodein lazy. What is that? Well, as you all know, an application is really ready only when the onCreate method is called. So we could not really declare our dependencies right away when the application object is created. So by using lazy, you're ensuring that the Kodein code will be run only when it is needed, which means only when the application has properly initialized. This allows you to import a standard module that we will talk about, because Kodein gives you a lot of features for Android, and this is a weird code, a lifecycle callback. Note that it is entirely optional, and we will come back to that. You usually use this code only when you want to do weird stuff. Most of the time, it's not needed. Okay, so we want it. We want the library to be also idiomatic, which means that it should feel in KOtlin, it should feel native, it should feel regular inside the KOtlin. So, let's say I have access to a Kodein instance, I have a class manager, I want a DB, I want an instance. I could have gotten it via constructor parameters, but if I have a Kodein instance, I could very well ask an instance. And the same thing that I said is true. It still uses REIFIED generics, which means that the type is inferred at compilation. There's no reflexivity involved there. Okay, so you can ask for an instance, and there you go. You could ask for a provider. What is a provider? It is a simple function that will give you an instance every time you call that function. Well, ask for a provider. The same thing is true for a factory, if you, but it has an argument. And what about currying? Sometimes I want a preference repositories, and I don't want to have to retrieve the factory, then call the factory with an argument. With Kodein, you can simply say, okay, I want an instance of factory. I know it is bound with a, I want an instance of preferences. I know it is bound as a factory, so I'm giving you the argument, so I don't have to pass through the factory. I'm sorry, because I think only French people can understand what is Jean-Claude Van Damme doing here. The question is, are you Kodein aware? So we saw the interface earlier. Kodein aware is a simple interface that basically says, okay, you know where to find a Kodein object. I trust you. You know where to find a Kodein object. So why would we do that? Let's take back our MyManager class that has a Kodein instance. Okay, the first thing we would do is to make it Kodein aware, then Kodein would be an override. Now we know where to find a Kodein object. As a matter of fact, it is literally passed as the constructor. Why would you do that? Because that. Now it feels even more readable. I want a DB, it's an instance. GetRandom is a function, it's a provider. I don't even have to reference the Kodein object. It feels really in I don't know, maybe 20 characters. You understand it's semantic, it's idiomatic. Here's a cool trick, by the way. Let's say you have a logger class, and that logger class functions like every logger class in the world. It takes a class as a tag, and it will use the name of the class as the tag. Well, you register the logger class with a factory that take a class as parameter and returns a logger implementation, and then you use it with the carrying notation that we've seen earlier, which is I give the parameter, which is the class of the object, so Java class, and I get the logger. The cool trick is to declare an extension function to Kodein aware so that it does exactly the same thing with Java. So now whenever you need a logger, you can just get a logger instance. That's a cool trick that is enabled by KOtlin and Kodein. Okay, so how do we get lazy? Android has a problem, or more specifically, Android classes have a problem, and that problem is that an activity or fragment or component or what have you is not really initialized before onCreate. Okay, that's a weird. I don't know why the Android system team chose to do that, but when the constructor of your class is called, well, the class isn't really initialized. You have to wait for onCreate. So let's get lazy. Being lazy means that we are not going to access our properties before we need them. And when we need them, we know that the class has been initialized because it has called onCreate. So instead of being Kodein aware, we could be no, sorry, this is an error. Yeah, okay, okay, I'm sorry. This is an error. Why is it an error? Because there's an equal everywhere, and this code is run at initialization by the just before the constructor. onCreate has not been called. So you know how it works. Let's fill in the blank to correct that. But before we fill in the blank, I want to attract your attention to the fact that I'm speaking about Kodein 4. Kodein 4 is the released version. Kodein 5 is currently being developed. It's in progress. And there's a big difference between Kodein 4 and Kodein 5. Kodein 4 is direct by default, while Kodein 5 is lazy by default. Which means that what I'm showing you today is not necessary in Kodein 5, but right now it is. And developing for Android in Kodein 4 is easy, but in Kodein 5 it will be even easier. So let's go back to our example. And our example says this is failing. Okay, so let's change that. First, let's be lazy. So let's implement lazy Kodein aware. Then let's have a lazy Kodein instead of a simple Kodein. And finally, let's change this equals by a by. Okay, lots to see here. First, app Kodein, what it is. It's simple. It's simply a function that's provided by the Kodein library that says, okay, the Kodein object is in the application object. I know where to find it. Why did we change the equals by the by? It's a Kodein construct. The equals means that the instance function is called directly. The by the way, this is another instance function. This instance function is called immediately, but it returns a delegate, and these delegates will call the Kodein on needed. So by using this syntax, we can ensure that our application will not crash because everything will be fetched only when needed. Okay, so there's another construct, and it's called being injected instead of lazy, and it means that we could retrieve all dependencies at once when needed, instead of getting all when needed. Now we retrieve all at once. So let's get back to our example. Instead of being Kodein where we are Kodein injected. And now the difference is that you create an injector. Now this is interesting because an injector is an object that has no notion of where to find a Kodein instance, which means that an injector has absolutely no notions of what are the bindings, what are the dependency, what is the dependency tree, and so on and so forth. Then the same thing is true. You use a by, meaning that it will be resolved later, and finally you inject at onCreate. That means that now all your dependencies that are used by the injector are fetched at that exact moment, and that means that makes it more readable. By the way, if you access this object before calling inject, of course it will fail because it has no notion of where to find a Kodein object. Let's talk a bit about Android niceties, but really quick. Here we use a here we get a vibrator. We could do better because we need to use lazy because the activity has not been initialized properly yet. We get this get system service with an enum, an int, sorry. Then we need to cast it as a vibrator. Well, if you use Kodein, you could just ask an instance just as any other dependencies. And there is this thing that is called Android subscopes that allows you to create scopes within activities and your fragments and your object that are and your views or what have you that are specific to this activity will get more things from this Kodein. You need to implement this Kodein activity and then bind it, and then in your fragment you can retrieve it. That's a binding that exists only inside your activity. Okay, you've seen that it is intelligence-based. Don't jump to my throat. There's of course an interface-based API available, and all this stuff is completely optional. You don't have to play with it. It's only when you have weird needs. Okay, now a bit of disclaimer. I'm going to talk about the future of Kodein. And that future is bright, but it's also foggy. So, of course, it may change, it may evolve. You get the gist. You understood that we are now going to talk about Kodein 5 and what it will add to your lives. As you've understood, it's lazy by default, which means that you won't have to do lazy stuff. It will do it for you, and you won't have to know if you have to use equals or by depending on the context. You will use by every time. It's receiver aware, which means that you don't have to do subscoping. Most of the time subscoping will be automatic because it has a notion of the receiver. You will be able to plug an external source which allows you to delegate to another DI should you migrate your app. By the way, these two features are used for an integration to TornadoFX, which is a great way in KOtlin to write JavaFX applications, which are client software applications. So I won't go into that. You won't need that weird syntax with etc. to carry. You will simply use named arguments to pass the arguments. And the question is, when will it release? And of course, the answer is, who knows? Finally, I've said that under that my DI system, my ideal DI system, should be compatible with another OS than Android. And let me tell you that Kodein 4 is already compatible with JavaScript, because KOtlin does compile to JavaScript, and KOtlin 5 will be compatible with KOtlin native, which is really amazing because it will compile to LLVM bitcode, which in turn compiles to processor assembly, which means that we will get to run our KOtlin code to Raspberry Pi. Yeah! Come on! Okay, there's also iOS, but you know, if you're interested. So, I can't lie because it's maybe it will not be Kodein 5.0 that will be Kodein compatible with native, because Kotlin native is missing a few parts, and as soon as those parts are added, then of course Kodein will be added to the native platform and compatible to iOS, and blah blah blah. Thank you for listening to me. You can access Kodein at kodein.org, and I hope it will improve your lives. Now I have time for some questions. Thank you very much.
Is it going to be compatible with Kodein 4, I mean version 5? Or you will need to make some adjustment?
There will be some adjustments that are needed. First and foremost, the package will change. It's actually it's now com.github.salomonbrys.kodein, and now that I've brought the kodein.org domain name, it will change to org.kodein, and some changes will have to be made, such as the with that becomes a named argument, the curring syntax that becomes a named argument because it's a lot more readable. I'd say that 80% of your code won't need to change. The binding syntax remains the same. The retrieving syntax that is except for this with part remains exactly the same. So a few things will need to change. You will need to re-import from to kodein.org, but the rest is source compatible.
So would you recommend it to use in a production code?
It's actually used by many applications around the world in production code. I say around the world because I know that it's used in Israel, in the United States, in France, because we use it. So yeah, I would definitely recommend it. It's stable. Okay, thank you guys, and enjoy.